Principal Dr. Premasi sir for his continuous support and encouragement. I welcome the deans, directors, HODs, and faculty members from our college and also from various colleges in and around India. It's my privilege to introduce the chief guest of the day, Dr. Sujit Jaiprakash, Director and Business Head, New Age Infotech NIT Ghana. Dr. Sujit is a highly motivated business development professional with a strong background in IT training and administration. He has completed his doctorate in computer science with a specialization in education in data mining. Dr. Sujit is a certified Microsoft trainer and Microsoft certified professional developer. He started his career as a technical trainer and gradually rose into the profile of academic head and center manager. He has over a decade of experience in the education sectors in India, Africa, and Latin America, with significant experience in senior management roles and leading institutional academic delivery improvement. His area of expertise includes data science, education data mining, web mining, and social media marketing. We are very glad to have you here, sir. Now, the session is yours. Thank you.
Thank you, ma'am. Um, Good evening to all. Much delighted to be here. I could see a whole lot of academic fraternity across Tamil Nadu and beyond that. Um, Quite a nervous session, I believe, because I could see some of my mentors like Dr. Bala, Dr. Sankita, and a whole lot of academic, high quality professionals here in this webinar. Um, so, let me quickly start with this session. And first of all, I would like to thank the principal of Dr. SNS Rajalakshmi College of Arts and Science, the director and the head of the department of the MCA department for inviting me to take this webinar. So as you all know, the topic of today's webinar is machine learning, the next generation aspect. Uh, to better the quality of this webinar, I would request everyone to switch off your videos, and I'll do the same. And also please mute so that everyone can listen to what I'm saying. So um, also the time is not normal. For example, everywhere it's COVID pandemic is there, and I hope everybody is safe and healthy. And as Dr. Shanmugapriya rightly said, I'm Sujit Jayaprakash, currently working as the director and the business head of New Age Infotech, which is based in Ghana, and West Africa. And I have a decade of experience in education administration and a fair bit of knowledge in technology, higher end technologies like Python, data science, web mining, education data mining. And so today's topic is going to be an introduction to machine learning. And I'm pretty sure that most of you in the academia must have tried your hands in the field of machine learning or data science. So for some of you, it's going to be a new thing. However, this particular webinar is solely focused on introducing you to the machine learning. Um, Sorry, please mute your microphone so that the webinar will go without any distraction. Thank you. So I would like to start with a small disclaimer though, because I saw a whole lot of people who are research scholars and PhD holders. So this webinar is solely focused on introducing to machine learning concepts, and hence most of the topics I'm going to deal here today would be just an introduction. And so if you are already having a fair bit of knowledge and experience in machine learning or data science, then you might find this webinar to be of less interest to you, or you might not get what you're expecting. So for those, which is going to be for those, the machine learning is quite a new concept. I can tell you that this webinar is going to give you more details about it, and will give you a fair bit of experience on how this machine learning algorithm works. So cheers, and let's start. So what is machine learning? And it's a quite common thing that whenever we want to learn something, we start with the definitions from reliable sources. And I also picked the same thing here. So some common definitions from the reliable sources. For me, those reliable sources are Wikipedia and O'Reilly. So based on this Wikipedia concept, machine learning is the study of computer algorithms that improve automatically through experience. Um, it's just a sentence, right? A simple sentence, but a whole lot of meaning inside it. um, so it's a study basically of computer algorithms, using computer algorithms which improves automatically through experience. So in the later part of the slides, when I'm introducing you to some of the concepts of machine learning, I'll explain you this particular sentence in a detail. But for now, what you have to understand is machine learning basically works with algorithms, computer algorithms. It reads from the historical data and produces output, or predicts output. So that's what a machine learning is. So there is another definition from O'Reilly, that's from Sujit Pal and Antonio Gulli, and surprisingly, he holds the same name like me. So machine learning is a subset of larger field of artificial intelligence, and that focuses on teaching computers how to learn without the need to be programmed for a specific task. So what we are trying to say here is that machine learning tries to learn by itself without any human intervention. So once the models are trained, so it will work by itself without any human intervention. Now, um, you might be surprised to see these Avengers and Hulk and all those things, all these guys, big guys, and we call them superheroes. And currently, those superheroes are our artificial intelligence, machine learning, deep learning, data science. And without them, there is no technology in your day-to-day life, in your everyday life. You are coming across all these big guys like artificial intelligence, machine learning. Everything is crossing you in every few seconds of your life. For example, when you pick up your mobile phone, that's there is artificial intelligence, there is machine learning. When you sit in front of your laptop, when you sit in front of your television channel, the adverts which are running on the television channels, those targeted adverts which are targeting you to sell their products, every single thing around you is today artificial intelligence, machine learning, deep learning, data science, and all those things. And these are really the superheroes, because without them there is no business today. So but then most of us use these words quite interchangeably. For example, many of you might be thinking, what is artificial intelligence, what is machine learning, what is a neural network? And some of you might think all these are same, right? Sound same. We don't know what exactly it does, and who is the father of all these things and all stuff. So this particular slide is going to explain you what is
Sir,
which.
excuse sir. Uh, Sir, PPT is not visible, sir.
I'm sorry. Thank you for notifying that.
Sir, excuse me, sir.
Okay, so
Sir, excuse
I
me.
don't want to take it over.
Sir, sir, few of the participants are still waiting for your acceptance. Please accept them, sir.
Sure, ma'am. Um, I don't see any request, ma'am, yet.
Then, okay, sir. You can
Okay,
continue.
thank you. Uh, I'm terribly sorry. So I thought the slides are running. So, anyways, we have covered most of this, and this is what a machine learning is, which I was discussing about. And okay, these are the slides. And I guess when I mentioned about these Avengers and superheroes, that's why you realize, that's how you realize that the slides are not on. Thanks for that. So as I told you, so this particular slide is going to give you Thank you. So this particular slide is going to give you a difference between what an artificial intelligence is, what deep learning, what neural networks, data science, and machine learning. So as I said, artificial intelligence is the main thing which holds all the other things. When you talk about machine learning, when you talk about deep learning, neural networks, everything is a subset of artificial intelligence. I can say that, and it's kind of a Venn diagram concept because data science sprawls across all these things. So let's start with artificial intelligence, which is AI is for building models that emulate cognition and human understanding. In simple words, artificial intelligence is used to mimic human behavior, like how a human does. Mimicking that is called artificial intelligence. For example, your robots, right? So robots are called artificial intelligence, that basically mimicking what a human behavior, what a human does. So it's building model that emulate cognition and human understanding, and it is also the implementation of predictive model to forecast future events. Today we are forecasting quite a number of things. For example, when this COVID pandemic happened in Wuhan, and now people are saying that by in the month of July or August, things might settle down and everywhere things will get into normal. All these things are predicted not just because of somebody's what do you call um, some fortune teller has told all these things, not really like that, but then they have actually worked out with the data what they have. So they have analyzed a whole lot of historical data to predict something, and that's how even the weather is predicted today. So artificial intelligence holds or plays a major role in all these things. Now the next thing is, straight away let me jump into machine learning, which is a subset of artificial intelligence and today's topic. And machine learning is an application of artificial intelligence, and which provides the system the ability to automatically learn and improve from experience, which I have already explained. Now let me jump into deep learning, because deep learning is a subset of artificial intelligence or machine learning. Basically, deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. Now you will get a better understanding of how this falls down. So deep learning is a subset of machine learning that has networks capable of learning unsupervised from data that is unstructured or unlabeled. For now, it might be confusing for you, that is like to understand what is unstructured, what is unlabeled. Eventually, when I start explaining you the different types of machine learning, you might understand, or you will better understand this. Then we get into this neural networks. Neural networks or artificial neural networks or CNN, all these things are part of deep learning techniques. And that is also a subset of machine learning, you can say. And neural networks is kind of mimicking a human brain, like how human brain works with neurons connecting different activities of a human body. So that's how this neural network also works. So there are algorithms like back propagation algorithm and stuff. So that's what you work with neural networks. And finally, we come into data science. So as I told you, to get all these things done, artificial intelligence or machine learning, all these things, you need data, right? There is a whole lot of data generated every single day from any individual in this world. So to analyze this data, to find or to get insights from the data, the art of doing all these things is called data science. So data science is about finding hidden patterns in the data, and it comprises of various statistical techniques. So the data which we take from using the data science, the data which we extract using the data science is applied into these machine learning models or to build an artificial intelligence model. So if you could say that, I mean, you can see that the data sprawled around all these things, machine learning, deep learning, artificial intelligence. So without data, you might not be able to move forward. So data plays a major role in everything we do these days. Let me back my argument with all these examples, real life examples, which you come across every single day. Um, before I get into this, now here you can see some of the things like Google Maps, face detection, video surveillance, product recommendation, sentiment analysis, AI in agriculture. I want any any two of you to talk about some real life examples of machine learning, just to understand um, how well you have taken this machine learning concept. So any two of you can unmute your mic and then explain me. I mean, give me an example, a real life example of machine learning. I think Ms. Purnima is out there, so she has unmuted.
Yes, sir, fingerprint recognition for opening the mobile phones.
Oh, that's great. Yes, ma'am. That's right. Fingerprint recognition. Yeah.
Sir, Google Maps.
Perfect, ma'am. I think it's Dhanalakshmi Venkatesh, Miss Dhanalakshmi
Yes, sir, I'm done.
Venkatesh.
Yes, sir.
Thank you, ma'am.
Then the Google Voice Search.
Yes, I think it's from Miss Umarani. Yeah, thank you. Thank you.
Sir,
So,
recommendation systems.
Mr. Mahesh, yes, it's a recommendation system. I'm sorry if I'm not using the right title of doctor or Mr. because I'm unable to figure it out here. But thank you for all your examples, and you guys have a fair bit of knowledge and idea about what are machine learning and some of these examples, right? Now, I have mentioned some of these examples here. So one is like Google Maps. Some of you rightly mentioned that. Then we have face detection, video surveillance, product recommendation. So let me explain you one by one. For example, when you talk about Google Map, I told you data is important everywhere. So how does Google Map knows that you're on the fastest route despite the traffic is high? Assuming you have taken your car to hit on a road and then you have put up the direction over there, and automatically your Google Map redirects you to some other way because either the road is blocked or maybe because there is a huge traffic out there. But how does this Google Map knows? So basically, it's a combination of multiple factors, like how many people are currently using the service of Google Map, historic data of that particular route, and some real-time techniques. So all these data are put together and algorithms are applied on that to find out the optimum solution for this, right? So basically the Google Maps, you're allowing the app to use data like your location, you're allowing the Google Map to use it. That's quite default. When you install Google Map on your phone, you're automatically allowing the Google Map to use your location, the average traveling speed of your car to determine at what time you will reach to the particular destination, and answers to the questions like does the route still have traffic and daytime and any specific occasion. So all these things are taken into consideration when a Google Map gives you an optimum solution of or directing you to a particular direction. So all such data is captured and stored by the application. So by using this data, artificial intelligence and machine learning algorithms makes the right conclusion and gives you the exact information basically. So that's how it works. And next thing is by default this face recognition. And recently, in the recent past, we all have seen that many of us buy expensive mobile phones. Like for example, I think OnePlus or iPhones or a whole lot of mobiles have come up with this face detection, and we always flaunt with this face detection technique we have on our mobile phones, right? So how does this works? And the technology behind this is again artificial intelligence and machine learning. Not only in face detection. So, for example, when you use drones, drones are using image recognition. Manufacturing, when you go to the Tesla, you must have heard about Tesla. So Tesla makes these automated cars and other things. So they also use a whole lot of technologies, and then artificial intelligence and machine learning are part of it, and to make these self-driving cars. And also they use in military surveillance, forest activities, and everywhere you will find this video surveillance or face detections are used. So especially these days, video surveillance are used. Video surveillance. Yeah, sorry, ma'am.
Sir, many are messaging me that they couldn't able to join, sir. Could you able to check it out once again, sir?
I'm not getting any request here, so I'm surprised.
They are sending the screenshots to you, sir. They are just asking to join.
Should I stop the recording? I don't know if that is causing the problem because. Yeah, you can see here we are not getting any requests, so I'm just surprised.
Sir, in chat box also we are getting messages, sir.
Come again, ma'am.
They are asked to admit.
Okay, I'm going ahead with this. So because I don't find any notification or anything here. You can see my screen, right?
Yes, sir. Yes,
Dr.
sir.
Shanmugh, right? Yeah, you can see my screen, right? So I'm not able to see any of the requests yet. Okay, so coming back, I'm sorry for that interruption, and coming back to this discussion. So the next thing is sentimental analysis. So I wanted to know if anybody knows about the sentimental analysis. So one of you can unmute your mic and tell me if you know what is a sentimental analysis is. Anybody who has an idea of what a sentimental analysis is? Okay, so let me go ahead then. So basically, sentimental analysis refers to the opinion mining and analyzing emotions. For example, it is largely used. Sorry, Madam Shanmugh, can I unmute you, please?
Yes, sir.
Thank you. Yeah, so sentiment analysis refers to the sentimental classification, opinion mining, and analyzing emotions. So, for example, I am a movie buff. Like, for example, I love watching movies, and we all know that in India, every Friday, like 9 to 10 movies would be releasing. And within like 30-40 minutes of time, you'll be able to see the reports of the movies, or the social medias will declare whether the movie is a hit or a flop. So, how does this happens? So basically, this also happens with a whole lot of data which is collected across the social media pages, and they apply sentimental analysis algorithm on that. So for example, using, I mean, it's a machine learning model, then these models are built to groom the machines themselves to analyze sentiments based on the words. So they can identify if the word are said in a positive way, negative way, or in a neutral way, and they can define the magnitude of these words. That's how the sentiment analysis works. So for example, in Twitter, in Facebook, and if people starts tweeting about a particular movie in a very positive note, so they will analyze all those words, and these words are kind of applied in a machine learning model, and then they will come out with an output where how many people have said a positive note on this particular movie, or how many people have made a negative comment on this, and based on all these things they will declare whether the movie is a hit or a flop. So this is a very basic example I could give it to you. Apart from this, it is used, sentimental analysis is adopted in multiple places. So for example, effective branding and social media monitoring. Assuming a big brand like Ford, or a big brand like in India, I could say, I mean, any brand you take, whenever they release their product out there in social media or out there in the television channels, they will, first thing what they will try to observe is the sentiment, like whether the product has been liked by the people, how many people are commenting positively about it, how many people are commenting negatively about it, and based on that they will come with changes on that. So it has helped in effective branding and social media monitoring. The next thing is enhanced customer support. So assuming a customer who's coming to your website is not happy and then he's keep on registering negative reviews about your websites or negative reviews about your products, and based on that you can rework on those products and then you can enhance the customer support. And then the competitive analysis, it's also used for better tracking of employee feedbacks and user generated content like reviews. So in various occasions and in various places we are using this sentimental analysis, and it's all machine learning, by the way. And next one is product recommendation. So this is everyone must have seen this product recommendation, how it works, and you all must have you all must be having this Amazon Prime account or Netflix account, or let's say Amazon or Flipkart, all these accounts, right? So whenever you scroll through it, you will find that they will recommend some of these products. And how does this product recommendation works? It works because it searches the site-wide history of a particular customer. It searches for your interest. It searches for what you have checked already. So based on all these things, the products are recommended. I don't know how many of you have experienced this particular part where assuming you want to book a flight and then you have gone to any of the airline website and then you tried booking this flight, somehow you exited from it. uh, Eventually you will see that a whole lot of flight advertisements must be following you on Google or on Facebook or anywhere. This happens because it's called targeting or retargeting of customers, and these are all the basic built-in things when you are doing, yeah, when you are doing Google AdWords, for example. So if you have an idea about what a social media marketing is, um, in Facebook marketing and in Google AdWords marketing, there are different types of marketing. Like you can do search ads, you can do display ads. So there are possibilities that you can do retargeting ads. For example, if a customer comes to your website and if he goes back without purchasing any product, you can target that customer till the time he is again bouncing back to your website to buy that product. So this also happens using this also happens because of AI and machine learning, and that's called the product recommendation feature. And these days, AI is also used in agriculture. For example, some even Tamil Nadu government has used artificial intelligence and IoTs for to avoid illegal minings. So, for example, when people are taking out the sands from the riverbanks and other places, so automatically the sensors are there which sends out signals to the server room, and from there, these signals are captured and the data is taken. Machine learning models are applied on it, and then they come out to the conclusion that in this particular location they are trying to do an illegal mining or whatever it is. So even government has taken several steps using artificial intelligence and machine learning to prevent some of these cyber crimes and stuff. And also it is used in agriculture and things. So I've been giving you a whole lot of examples. So let's delve into the real machine learning concepts. So when you talk about machine learning concepts, machine learning helps you to use historical data to make better business decisions. And this is the most important thing. Based on the data, you train a model or you train a system to predict the future or to get an outcome based on your historical data. And machine learning algorithm discovers patterns and data and construct mathematical models. So it is also used to predict the future data based on the historical data, as I mentioned in the first point. So let's get into some of the mathematical functions. So here you go, learning a function. Machine learning is simply mentioned like this: y equal to f of x. Y is your target variable, what you want to predict, what you want to achieve. X is the different features which you feed into the target function Y. So target function F. So Y equal to F of X. That's how we simply define machine learning. And let me explain this using product recommendation scenario. Assuming you are a programmer and you have been asked to develop a model which recommends products to the customer who are coming to the website. So there are two approaches you can do. One is a classic approach, which is very basic. What you would do is you will go through the purchase history of a particular customer, and then you will create rules. Okay, when this customer comes in, and these are the products he normally looks for, and then based on that you write a rule, and then you develop a software based on that, right? So this is a very basic thing. The second thing is machine learning approach. So how this machine learning approach works is you will build a model which takes out the purchase history of that particular customer, which also goes through and reads the site-wide customer access sales data. For example, there might be like uh, 500,000 or a million customers coming to your website every day or in a month. So the model goes and reads out the entire customer data and also a particular customer's purchase history. It also takes out the most recent purchases, and based on that it recommends. So this is how a machine learning model works. Now again, let me explain this in the machine learning terms. For example, you all know that computers understand zeros and ones. So this whole slide is going to explain you how machine learning recommends a particular product. So f of x is equal to, so you can see all these things, a0 x0 plus a1 x1, right? So now there are two key components in this algorithm. One is a feature, another one is a weight. So what I mean by feature, for example, x0 is called a feature, a0 is called a weight. What I mean by a feature is that whether features are part of data set that are identified as important to identify the outcome. Assuming if you want to identify if a particular student will pass in his exam or not. Let's say you have a student database with all his marks, attendance, name, phone number, and everything, and you are trying to identify whether the student will pass or fail based on the historical data. So do you think the phone number will make any sense here? Do you think that those features will help us to predict whether the student will pass or fail? Or do you think a serial number in the data set will help you to find out whether the student will pass or fail? No, right? So basically you have to identify features that are relevant and that can help you to predict the outcome. So features are that, and weights are to determine how important those associated features are. As I told you, maybe you are having a 10,000 student record. Out of that, only 2 records are having let's say students gender, like for example male and female. You have 9,998 records are for male candidates and 2 records are for female candidates. Using that gender column, definitely you will not be able to predict an outcome because it's totally irrelevant. So that's why you need to understand the weight also. So there are features, there are weights, 2 things you have to identify and work according to that. So let's take this example. A customer is coming to buy a shirt, right? So the first thing you will identify is whether is the product a shirt. If it is a shirt, yes, then your value becomes 1. Now the weight is how much does the feature affect the accuracy of the prediction. That's what the weight is. So the question is, this customer has purchased 8 shirts in the past, so which means it's relevant. You can definitely use this particular feature of shirt to predict the outcome. So now weight is equal to 0.8 based on that. So a0 x0, so if you see down, like 0.8 times 1, that's what I've mentioned. Now next thing you are going to identify is this item from a particular brand? So here I have mentioned a brand called Peter England. So what are you going to find out is, first of all, whether it is a shirt, and if it is a shirt, how many times he has purchased shirts in your website, and has he purchased a particular brand before? So if it is yes, again, how many times he has purchased that particular brand? So for example, here he has purchased two shirts of the same brand before or in the past. So then the weight becomes 2 divided by 8 is 0.25. Now your calculation goes like this: f of x is equal to 0.8, which is the first feature, times which is the weight times first feature, plus the weight times the second feature. Together, when you sum it up, it comes to 1.5. So whenever you get anything above 1, if the function f of x, the target function, is greater than 1, then you can recommend this particular product to the customer. So this is how machine learning works. So you build a model. Okay. So you build a model, you assess its weight, you assess its feature, and then you will see whether this feature is relevant and whether this feature can recommend a particular product or a particular output. Based on that, you will recommend. So we have come into the very important part of this webinar, that's called the categories of machine learning. Whenever anybody talks about machine learning, whenever some people say that they are doing a research on machine learning, it falls under any of these three categories. So supervised, unsupervised, and reinforcement. These are the three different categories of machine learning, and all the machine learning algorithms falls under any of these three categories. So let me start with what is a supervised machine learning algorithm. It's pretty simple. So if you see the definitions what I've given here, a supervised learning is a machine learning task of learning a function that maps an input to an output based on example input output pairs, right? It infers a function from label training data consisting of a set of training example. So it's quite tricky or difficult to grasp these points, but let me give you a basic example. Supervised learning is, you have a fixed set of inputs, you know what is the output, based on that you're going to work. For example, I told you the example of predicting a student result. If you want to predict a student result, whether it is a pass or fail, you already know this is what you're going to predict. You're going to predict whether he's a pass, he's going to be, I mean, the student has passed or failed. These are the two things you're going to predict with multiple features in hand. So you know what is the input, you know what is the output, and when you work in such an environment, when you work with that, that's called supervised learning. So with supervised learning, you feed the output of your algorithm into the system. What you need to do is, first of all, you have to train a model. So let's say when you're building a machine learning model using supervised learning, first and foremost, you have to train the model. How will you train the model? Is you will upload or you will load historical data into it. So based on the historical data, the system will assume, okay, when these features are met, this is how the outcome is going to be. So that's a basic thing, and that's how supervised learning works. So a basic example of this concept would be a student learning a course from an instructor. So the student knows that he or she is learning from the course. So because the outcome is already known, the input is already known, and putting it together in a model, it's called a supervised learning. So with the output of the algorithm is already known, all system need to do is work out step or process need to reach from the input to the output, right? Um, at the end of this webinar, uh, I'm going to take you through a demonstration of using supervised learning to predict whether the student will be admitted to a particular program or not. So then you might get a better understanding of this. So the input variable x is used to connect with the output variable of y through the use of an algorithm. So here y equal to f of x, when I told you, so where y is the output which you have to predict, x are the number of features, f of x is the machine learning model. So in that you can apply any of the algorithms, right? Now, why supervised learning? Uh, First of all, it allows you to collect data or produce a data output from the previous experience, and it's very um, easy to understand, easy to interpret, and easy to learn. So it also helps you to optimize performance criteria using experience. And supervised machine learning helps you to solve various types of real world computation problems. Today, any real world problem, if you take, for example, predicting the weather, or for example, the vehicle automation, or any problem you take, product recommendation, everything you take, this all works based on the supervised learning model. um, for example, let's say the product recommendation feature in Amazon Prime. If you guys are using Amazon Prime, when you log in, it automatically gives you regional wise movies. It automatically recommends you regional wise movies. That is because it knows that the output is going to be filtering out regional wise movies. The features would be how many times you have watched those kind of movies, which movies are of your own interest, and everything put together. You will understand. You will come out with an output, or you will come out with, you will cluster those kind of movies. So that's what supervised learning is. And basically, there are two different problems we deal in supervised learning. One is classification, another one is regression. Classification problem categorizes all variables that forms the output, right? So example of these categories found through classification would include demographic data such as marital state, sex, or age. Again, coming back to the example what I gave you, if you want to predict whether a student has passed or failed in his examination, pass and fail, it's a categorical variable. So this falls under classification. um, if you want to predict whether it is going to rain today or not, again it is a classification. If you want to predict there will be traffic or not, it is a classification example. So all these classification examples comes under classification problem of supervised learning. And you might ask, what would be regression then? Regression problems are basically when the output variables are real numbers. For example, you are developing a product to predict the stock market price tomorrow. So you know that stock market price is always in real numbers, or it's always currencies, right? So when you want to predict a stock market value, that's where the regression comes. When there are real numbers, or if you want to predict somebody's score, test score, if you want to predict how much runs India is going to take based on the number of overs they have played, based on number of feedbacks they have received. So that's also kind of a regression problem, right? So there are two different problems comes under supervised learning. Now comes unsupervised learning. Unsupervised learning is bit tough in terms of implementing, because here you don't know what is the output is going to be. You want the system to learn from the historical data you have provided. So unsupervised learning is a type of machine learning algorithm used to draw inferences from data sets consist of input data without labeled responses. You are just feeding the data. From that, the system should come out with an output. So the most common unsupervised learning model is the cluster analysis. Let me give you another example of unsupervised learning. Let's say you take the case of a baby and a family dog. Let's say if you have a baby in your house, a child, and you have a dog in your house, right? So this baby looks at this dog because, let's assume that it's a baby boy, and this baby boy has not seen any dogs outside. He has seen only the dog which is inside the house, and he knows that the features of the dogs are, it has 2 ears, it has a tail, it has 4 legs, and all those things. Now your neighbor comes up with another dog inside the house. Nobody has taught this baby that this is a dog, but automatically based on the features which is in his mind, he automatically predicts, okay, this is also going to be a this is also a dog, so it groups it. For example, your dog in the house as well as the dog from your neighbor's house, it groups and considers that, okay, they all fall under one particular category. So that's how this unsupervised learning works. So unsupervised learning finds all kind of unknown patterns in data. Um, So here there are two problems we deal again. One is the dimensionality reduction and clustering. So what clustering means is grouping. Clustering in simple words is called grouping. For example, um, if you take, let's say, if you want to group people who are having cholera in a particular um, village, so you are going to feed in all the data of that particular village, and then you are going to find out how many people are having this particular cholera disease and what are its features, and maybe you will find that all these patients are from a particular region, so you are going to cluster it. So like that, without knowing what the output is going to be, you are trying to put your data out there, and from the data you're going to cluster based on the events. So clustering can be considered the most important unsupervised learning problem. So as every other problem of this kind, it deals with finding a structure and collection of unlabeled data. Dimensionality reduction is sometimes if you want to extract a feature, if you want to expand a feature, if you want to re-engineering a particular feature, that's why dimensionality reduction comes. And dimensionality reduction is the process of reducing the number of random variables under the consideration by obtaining a set of principal values. When you are trying to read a data, when you're trying to cluster it, you will automatically try to find different features. And there are chances that one feature might multiply into two or three. So though all these feature engineering and feature selection, feature extraction comes under this dimensionality reduction. So as I explained you, there are mainly two things: supervised, unsupervised. There is also semi-supervised. We are going to we are going to see that soon. So you have supervised, you have unsupervised. Supervised has two problems: classification problem and a regression problem. Unsupervised has dimensionality reduction and clustering. These are the two things. Now you may ask, like, what are some of the algorithms which comes under all these supervised learning and unsupervised learning? The algorithms are basically, as I told you, supervised learning. Under classification, you have some algorithms like support vector machine, discriminant analysis, naive Bayes, nearest neighborhood, neural networks. Mainly people start with naive Bayes algorithm whenever you start learning supervised learning algorithms. Under regression, you have linear regression, support vector machines, and ensemble methods, decision trees, and neural networks. These are the other algorithms you have. And you also have clustering. Under clustering, you have k-means, k-medoids, fuzzy, hierarchical, Gaussian, and hidden Markov. So first of all, you need to identify, or you need to be clear with the problem you're going to deal with. Let's say if I want to build a machine learning model, I need to clearly understand what the model is going to do. Again, coming back to the example of a student in his examination, the reason why I'm keep on giving you this example is most of you are academicians and you can easily relate to what I'm trying to say. If I want to predict a score in a test for a student, if I want to predict a score, then I might go for a regression problem. Or if I want to predict whether he will pass or fail, or whether he will get a first class, second class, or second class upper division, then I'll go for a classification problem. And one thing you should understand is there is a technical term called no free lunch theorem. So what no free lunch theorem means is that it's not like one algorithm will uh, will work for all your problems. So based on the model, based on the data, some algorithms might work perfectly, some might not work. So you have to actually try different algorithms, or you have to rework on the existing algorithms to fit your model or to come with a better accuracy rate. Now comes reinforcement learning. So this reinforcement learning are also called as semi-supervised learning, which means you will give in some set of historical data though, but you will allow the model to build itself.
The slide is a bit.
Come again, ma'am?
So your slides, sir.
Are you not seeing the slide?
Yes, I can't see, sir.
I'm stopping it and sharing it again.
Okay.
Is it visible, ma'am?
Yes, sir.
Okay. So as I told you, these are the two different types of machine learning models. The next one is a reinforcement learning, which I was explaining to you. It's called a semi-supervised, where you will let the system to learn by itself based on a little bit of historical data you have already given. For example, a system interacts with a dynamic environment in which it must perform a certain goal, such as driving a vehicle or playing a game against an opponent. Um, I don't know how many of you have noticed this. If you're having Google Photos on your mobile phone, um, um, if you have a Google Photos on your if you have Google Photos app on your mobile phone, you will see that it randomly asks you to compare two people. Like it will show the pictures of two people, and it will ask you whether they are same or not, whether they are identical or not. I always face this problem because of my twin girls. Whenever I put out my daughter's pictures out there, it randomly picks up some old pictures and then shows whether these two pictures are same. So the system is trying to learn by itself. That's called reinforcement learning, and that works with the agent and an environment model. So if you see, a system integrates with a dynamic environment in which it must perform a certain goal. Like even a chess game, how does a chess game work? Is basically they will put out the rules there, how to play a chess, how to move your rook, how to move your queen or king, or all these chess coins, how it has to move, and some basic models will be already built in there. However, the system starts learning when it plays with a human. So let's say I'm going to uh, play with the computer. When my moves are better than the machine automatically picks up those moves and then saves it and then stores it. So it reuses it again. So that's called the trial and error kind of method. The machine tries something of its own. If it works out, that's called a reward. If it doesn't works out, again it moves back to the previous state and tries in a different steps. So reinforcement learning can be understood using the concept of agent, environment, state, action, and rewards. So as I told you, and this is a typical example in usual circumstance where we need to work on an autonomous vehicle to put safety first. So, I mean, whenever you are building an autonomous vehicle, assuming you build an autonomous vehicle, the first and foremost thing what you have to care is the safety of people who are sitting inside, and minimizing the ride time, reducing the pollution, offering the passenger comfort. You'll not be bothered about in what speed the car should go, how much. So that will not be your first priority, right? So with an autonomous car, on the other hand, so you will emphasize the speed much more than the driver's comfort. And the programmer cannot predict everything. So that's what I was saying. You will give the basic features in it, and based on the trial and error of the system, it automatically understands. So that's what reinforcement learning is. Let me. So these are some of the applications where all these concepts fall in. For example, supervised learning. When you say classification and regression, under classification you have fraud detection. Let's say when you receive an email, or if you want to identify a uh, financial fraud detection happens under the classification problem. If a customer is owing to multiple banks, um, it automatically flags him saying that he's a financial defaulter. Or if somebody is keep on doing fraudulent activities in multiple bank accounts, so he has been flagged as um, he is involved in fraudulent activities. So such kind of detection happens, and this is called classification. Email spam detection, you all know, whether the email has to go into your inbox or to your spam box. These are the two options. So it's not like only two options are there. there are thing called univariate and multivariate and bivariate. So when you say multivariate features, where there could be like more than two predicting variables. For example, if you want to assume a particular student whether he will fall into a first class category or a second class or a third class category, here comes there are three predicting features. So classification allows all these things, and you also have diagnostics, assuming if you want to predict if somebody is having a cancer, if somebody is having diabetes, all these things can be predicted using the history of that patient, also going through the history of other patients. So the only thing we are going to classify is whether he is having this or not. So again, it's a classification. Image classification. If you want to take a particular image and see whether this is taken in a daytime or a nighttime, based on the features involved in that particular image, you can clearly classify it, right? So these are some of the classification problems. Under regression, you have risk assessment, score prediction, as I already told you. Then when it comes to unsupervised learning, you have dimensionality reduction, text mining, face recognition. One typical example I can give it to you was when you buy a new mobile phone, right? So when you open your WhatsApp, you start typing things, and then you will find that whenever you start typing in your own mother tongue in English, you will find that the system is not predicting it when the mobile phone is new. Eventually, the system starts reading it. It creates a pattern. Okay, this is how you're going to respond. When you type, how are you? Like when you type how, it automatically predicts the next is going to be are, the next is going to be you. So it throws out all those predictions. So all this kind of happens because of these machine learning algorithms, especially dimensionality reduction. Because when you start typing, you have so many words. You would have used how for hundred of things, but it clearly reduces the features. It calculates how many times you have used how and how many times you have used are along with that how many times you have used you along with that are. Based on all these things, it throws out suggestions to you. So it happens through and it happens because of this unsupervised learning. Face recognition is another one, image recognition. And next thing is clustering. As I told you, when you are trying to predict a disease in a particular village or a particular place, when you're grouping a particular area, so this is called clustering. So it's used mainly in biology, city planning, targeted marketing, and all those things. Then the third one is reinforcement learning or a semi-supervised learning, where you have gaming, you have finance sector, you have manufacturing, inventory management, robot navigation. All these things uses reinforcement learning. These are some of the algorithms. So RL algorithms are basically two types, model free and model based. And some of these algorithms comes under model free reinforcement learning and model based reinforcement learning. Many of you might now want to get into this machine learning, and you might be wondering like which programming language I should learn, where I should start, and how I should work. For you, this graph is going to give you a solution. If you see, Python programming is widely used for data science and machine learning. So if you look at this chart, 76.3% of the people have used Python because of its easy to understand concepts, and then it's easy to implement. You can easily understand codes, unlike C, C++, Java, where you have to stick to a lot of curly braces and a lot of semantics and stuff. Python makes your life easier. So that's why many people move towards Python programming for machine learning and data science. And R is also another programming language which is commonly used for these machine learning concepts. And you have SQL, Jupyter notebooks, and whole lot of other things. But I would recommend you to stick to Python because it's quite easy for you to understand. If you have a basic programming language, you can quickly start working on these things. Now, there are a couple of machine learning tools also. There are libraries, because it's not like everybody knows how to implement an algorithm. Writing an algorithm is not an easy thing, right? So if you want to use some algorithms, there are so many libraries out there. You can just call it and then use it. For example, all these machine learning tools helps you to implement algorithms, work on your data sets and stuff. You have these are some of the tools which are also used for deep learning neural networks and stuff. For example, most of you academicians know about Veka, and some of you might be using Matplot and stuff, MATLAB, and I normally use scikit-learn and Python, and you have PyTorch. So many different things are there. So you can start with any. Let me start with the short demo of a supervised learning algorithm, how it works. So for this, I have used Python programming. Um, and just to tell you all these things, what I'm explaining you today, I have picked it from different sources, whether it is some website called Towards Data Science, or if it is Kaggle or Data Camp. I've picked this from different places. So now the problem in front of us is to predict graduate data. So this is graduate data. What we are trying to predict is whether a student will be admitted in a particular program or not, right? So there are different features for this. This is a data set. This data set has 400 records. These are the 400 records of different students, and this has different features. One is the GRE score. You all know that GRE score is used when we are trying to admit a student in an MBA program or other things. We also check the TOEFL score, like IELTS score, and you have university rating, you have recommendations, and you have CGPA, you have research data, whether the student is good in his research or not, and you also have chance of admitting. So the chance of admitting is based on multiple features like this, right? So we are going to build a model which is going to predict a student whether he will be admitted or not based on all the features we have discussed right now. For that, first of all, you have to import all the Python libraries. Let me first run this program so that you can understand. I've used three machine learning algorithms here, which is a random forest regressor, decision tree, and linear regression. These are the three um, regression algorithms we used. So if you go back to our slide where we discussed about different types of algorithms, we have linear regression here. I think random forest is not mentioned, but you have decision tree regression. Decision tree is here. So we are going to use these three algorithms, right? Now, let me run this. So what I've tried to do was, since I've used three different algorithms like linear regression, decision tree, and random forest, I'm trying to find out which algorithm gives me a better accuracy rate in predicting. So linear regression has almost linear regression and random forest are of the around the same level. So, but still, linear regression has given me a better um, accuracy rate. So I'll tell you how much is the. I'll show you how much is the accuracy rate here. I think it's not showing up. I'll also explain what this chart is. Okay. So if you see here the window, we have 81.73 for the linear regression, 77.97 for the decision tree, and you have 81.35 for the random forest. So if you see, a bit of accuracy rate is higher for the linear regression. So this is how it works. So it differs from model to model. The algorithm differs, right? Now let me explain you. The first and foremost thing is, okay. The first and foremost thing what we have done is we have imported all the Python libraries here. You have import NumPy, you have Pandas library, which has all the algorithms. You also have scikit-learn, and if you see here, I've imported the algorithm, linear regression, decision tree regressor, random forest. So all this comes under scikit-learning. So when I told you about this machine learning tools in one of my slides, um, yeah, so if you see here, there's a scikit-learn. So this is scikit-learn, which holds all the algorithms which you can use in your models. And now we have another thing called import Seaborn as SNS. So Seaborn is basically a Python data visualization library. Keep this in mind. You cannot straight away jump into predicting something. What you have to do is, first of all, you need data for that. You have to transform the data so that you can apply into the model. So collecting the data, working on the data is like 60 or 70% of your job. Applying machine learning algorithm to it is another, let's say, 15-20% of your work, right? And then the rest of the 10 comes in visualization to present your reports. So this is how it is divided. So first and foremost thing is, you need to be sure what problem you are going to work on, and what data you need for that, whether this data is you need to clean the data properly. For that, you use all the statistical methods. For example, if you see, when I ran this, so did you see this graph? So this is called heat map chart. So this is a Python chart. So the heat map basically works by correlation, and what it shows us which variable are highly correlated to each other. For example, here what I'm trying to understand is the chance of admit, how is it correlated to the rest of the features. So if you look at the blue shades of GRE score, um, that is one of the most important features what we have. And you also have CGPA. This is another important feature. So this heat map allows you to understand what are the most important features which are helping you to predict the output. So that's why we use Seaborn. So where you have fixed the settings. Now here is the case. My data set is in a CSV format. If it is saved in your database like SQL Server or anything, you would read in a different way. But since it's in a CSV format, comma separated values, I used pandas.read CSV, and I'm reading adm_ds.csv file from there. Now, it is stored in a data frame. So this df is nothing but the data frame. Um, So Python works with data frames, like it's a matrix of rows and columns, and in that, what I'm trying to do is I'm trying to change some of the column names, because there is a little bit of space here in chance of admit column. So I'm trying to change it and take out that space and then give a different name, and also for the reference. Then I want to drop some of the features which are irrelevant. For example, serial number we don't need, so we have kind of dropped it. Then these are the features of your heat map. Now I'm dividing it into two different variables. One is target. So the target is chance of admit. What you're trying to find out is the chance of admit the students. And next thing is all the other features except chance of admitting. So this is how it is divided. Now, what we are going to do next is use another feature of Python, which is a train test split. where you are dividing this particular data set. You are going to divide this particular data set into a training set and a testing set. So what we are trying to do is we are going to use 20% of the data as the testing. So let's say if it is 400 date records here, so you can say 400 20% is 80 records. You will be using it as a test, and the rest of the 320 you will use it as a training set. So I told you that in machine learning what you have to do is you have to load the historical data. So I'm going to load 80 records from here as a historical data, and I'm going to load other 20%. The other 20% I'm going to load without your chance of admit column. So what the system has to do is, based on the rest of the features, it has to tell me whether this person has a chance of admitting or not. That's what the model we are trying to build. So there is an 80% of the data is a historical data. Now, standard scalar is basically used, this feature is basically used to remove the mean and scaling to the unit variant. So let me come to the point. So one is a linear regression is the model we are trying to take here, algorithm. So in this, x underscore train is a training data, y underscore train is also another data. Now, what we are trying to predict is by applying the test, x underscore test. So if you see here, I've mentioned a feature called random stater is equal to 42. If you mention any integer number here, 0, 1, or 42, what does it mean is the data you are taking, the train or test data, first of all, it will be shuffled. Um, when I say 80% of training data, it will not be like first 80% of the record will be taken. It's not like that. It randomly takes any 80%. It randomly takes out records to make 80% of the historical data and puts it under the train. Similarly, test also, it takes any 20% of the data from here. So random state, what it happens is it doesn't allow the training and testing to shuffle again and again. So when you fix the random state, anytime you run this particular model, your train and the test data will be the same. Now, under the linear regression, you are trying to find out the score of the model you have built. So when you pass this test score, so if somebody wants to see what is X train and X test, let me show you. So if you look at that, these are the training data. Why the numbers are like this and why it is not like how it is shown here is just because we have used a standard scalar format, which basically converts into unit variance, which scales every parameter into unit variance. That is the reason. Um, let me print it here before we do this. Okay, here you go. So I've printed the train data set before I did the scaling. So if you see here, it just randomly picked any data for training. So 318, 202, 250, all these serial numbers it has picked. So let's say 3. So it picked this 322, 110, 3, 3.5, 2.5, 8.6. So it has just randomly picked 3, 18. You might wonder, here it is 3 and here it is 4. The reason is it starts from 0, 1, 2, 3, right? So that's the reason. And so it has picked up random training values. And then you can also show the test value. So these are the test values. Again, it is taken from 209, 280, 33, 210, all those things. So let's say so it's taken these values 0.68 and all. So now you understood that how this training and testing works, and how you can work with different algorithms. So there are several sites where you can start learning this machine learning. One site I would recommend everybody is Kaggle. I'll put out in chat. Maybe you can go through it. So using Kaggle chat, you can easily learn machine learning. So this is Kaggle, or you can learn from DataCamp. All these things, it's very easy and quite understandable. Being a novice, if you are a new person to machine learning, you can start from Kaggle or DataCamp. That's how we have come to the end of this presentation. I would like to thank Dr. K. Premnasir, the principal of SNS Rajalakshmi College, Dr. Kadresan, who's the director of SNS, and Dr. Shanmugapriya, who's also the head of the department of SNS, entire SNS team, and of course, you all for being here listening to me, and thanks for some of the positive comments.
Any queries, friends?
Yes, ma'am.
So I'll give my email ID and phone number here. So anybody who wants to get more details, I can send it to you. So this is my email ID and phone number.
Okay, friends, if there is no queries, we have come to the end of this presentation. First of all, I would like to thank our management for permitting us to have this wonderful session. And I thank our speaker, Dr. Subbu Jaiprakash sir, for giving a very good, wonderful presentation on machine learning. Sir, we all had a very clear explanation about the concepts of machine learning. Thank you, sir.
Thank you, madam.
Thank you very much for all the participants. Thank you all once again. Now we end the session. The feedback link is given. All the participants, please fill the feedback form for getting the certificate. Thank you all.